Hello students, in this video we are going to discuss more problems of the chapter exponents. So let's start. The very first question of today's videos is, if a equals to 2 to the power m, remember the value, if a equals to 2 to the power m and b equals to 2 to the power m plus 1. Remember, in both the cases base is 2 and in this case power is m, in this case power is m plus 1. Question says that find the value of, so that 8a cube by b square equals to m plus 1. You have to, so that let me write first. Now this is your question. First we have to find out the value of this complete LHS, then RHS, and then equate them. So let's start from left hand side. LHS, it's a 8a cube by b square. So we do different things at a time. 8, in place of 8 we can write down 2 to the power 3 into this symbol of into a. Value of a is 2 to the power m, but here a to the power 3, so whole to the power 3 divided by b. Value of b is 2 to the power m plus 1 and to the whole to the power 2. Clear? Hope this one is clear to you. Now come to this side. I am continuing from this thing. It's a 2 to the power 3 into 2 to the power 3 m, because we know from the laws of exponent power to the power must be multiplied. Here 2 to the power 2m plus 2. 2 is multiplied with complete m plus 1. Now base is same, so 2 to the power 3m plus 3 by 2 to the power 2m plus 2. Ultimately what we can write? See this side. So this, in this condition we can write, now both bases are 2, so 2 3m plus 3 minus 2m minus 2. Ultimately what we have? 2 to the power 3m minus 2m, m 3 minus 2 plus 1. What does it mean? It means left hand side equals to right hand side, hence it's proved. Hope this line is clear to you. Let me see the scene. Okay, that's clear to you. LHS equals to RHS, right? Likewise we can prove some other questions. Our next question is, solve such that no variables in denominators. You have to convert these expressions so that no variables in denominator. I am writing the question first. 12 x to the power 3 y to the power minus 2 z to the power 4 whole divided by 6 x to the power 7 y to the power minus 5 z to the power minus 3. We have to solve this expression such that no variables in denominators. No variable means these are not in denominators. How we convert? It's very easy. 12 by 6 into x to the power 3 minus 7 into y to the power minus 2. This moves to the upward, it's a plus minus of minus 5 now, it's a minus plus into z to the power 4 minus of minus 3. So we can write down 6 1 is 6 to the 2 12, 6 to the 12 into x to the power minus 4 into y to the power minus 2 minus plus 5 minus 2 plus 5 into z to the power 4 plus 3. So ultimately what we can write down, 2 to the power 2 into x to the power minus 4 y to the power 3 z to the power 7. Likewise we can solve all other questions. There are only 3 more questions left. You can easily solve likewise. Remember, in this case in denominators there is no variable, even no number is there. We simplify and change the sign of power which is present in denominator. Now in simplify we are going to solve some question. See here, it's a 2 to the power n plus 4 minus 2 into 2 to the power n divided by 2 into 2 to the power n plus 3 and plus 2 to the power minus 3. We have to simplify so that we can find out easily. So let's start. Keeping that base should be same, minus 2. Here both bases are 2, so 2n plus 1. Here see 2 to the power n plus 3 plus 1, that is 2 to the power n plus 4. We can write down 1 upon 2 to the power 3 likewise. Here we have 2 to the power n plus 4, 2 to the power n plus 1. So we can here we can write down this as 2 to the power n plus 1 plus 3 minus 2 to the power n plus 1 divided by 2 to the power n plus 1 plus 3 plus 1 upon 2 to the power 3. Come to this side and see, if we take 2n plus 1 common from both ends, what we have? 2n plus 1 common, then what we have? 2 to the power 3 we have, minus 1 into 2 to the power 3 common plus 1 upon 2 to the power 3. These two remove, cancels each other. We have 8 minus 1 by 8 plus 1 upon 8. So here we have 7 upon 8 plus 1 upon 8. It's a 8 upon 8, or it's a 1. So this is your solution. Remember, in this point, if we can find out 2n plus 1 common, then what remains? It's a 2 to the power 3 multiplied in multiplied form, because we know that if base is same, power must be added. So in this case power is added now, that's why we keep in multiply form and then we simplify. Hope this one is clear to you. Now our next question is, find the value of n from the given expression. Hope you can easily see, ink is a little bit lighter one, so try it, adjust it a little bit. we'll try in this case to keep the base part is same. So here we can write down 3 to the power 2 whole to the power n into 3 to the power 5 into 3 to the power 3 whole to the power 3 3 into 3 to the power 4 whole to the power 4. 3 3 is a 9, 9 3 27, 27 3 is a 81. The 3 3 over 4 81. Use implies that sign. It's a 3 to the power 3. Now bases are same, so we try to convert 3 to the power 2n into 3 to the power 5 into 3 to the power 9 by 3 into 3 to the power 16 equals to 3 to the power 3. Add them. 3 to the power 2n plus 5 plus 9 minus 1 minus 16 equals to 3 to the power 3. Ultimately, when we come this side, it's a 3 to the power 2n 5 plus 9, it's a 14, 14 minus 17, it's a minus 3 equals to 3 to the power 3. Now both side base is same, comparing both side equal, we can write down, therefore 2n minus 3 equals to 3, 2n equals to 3 plus 3, 2n equals to 6, n equals to 3. Hope this one is clear to you. See, in this side we have to prove that LHS equals to RHS. So we are using left hand side. So in this case what we do, first we convert x8 minus b whole to the power a plus b into x b minus c whole to the power b plus c into x c minus a whole to the power c plus a. I am solving only left hand side. So we can write down x to the power a square minus b square, a minus b multiplied by a plus b, x to the power b square minus c square into x to the power c square minus a square. Now here base is same, so we must add the powers. See very carefully, it's x a square minus b square plus b square minus c square plus c square minus a square. Ultimately cancels each other. A square cancels, minus b plus b, c plus c is x to the power 0, that is equals to 1, hence it's proved. Hope this one is clear to you. Likewise, we can use different laws of exponent to prove them. Now likewise, there are different questions to prove for provement or simplification type. In all of them we must keep one thing, that we make the base similar, then we use laws of exponent so that you can easily solve them. So that's all for today. All of you try to complete exercise 2 in your fair copy. All of you try each and every question 2-3 times in your rough copy so that you can easily solve exponent questions. That's all for today. Thank you.